And I'm recording as well here. So sorry, let me say it again. We're gonna do 7-4 today, 7-2 to do today, and 7-3 we're gonna do homework questions off of those.
I had a question on 7-2.
Which section?
Question 7 on 7-2.
7-7-2. Gotcha.
Because I thought that the answer would be that like, because there's an infinite number of solutions, but then in the back of the book it said like a something.
Huh.
Oh, if you go and read the beginning, it shows you the way that you meant to write it, because it's like infinite number is it can have whatever coefficient it wants. So it's like there's a specific way of writing it. I don't really know.
Okay, so for the solutions. Let me find out.
It's A302A minus 5.
Yes.
We're getting. Either that or we're going insane. Lego.
Lego Batman. I've never seen it.
Dude, Lego Batman movie was
So uneducated.
pretty good.
I learned black
That's-
and sometimes
Yeah, we always do Lego Batman.
All right, we're jamming now. So 7-2. Besides that, 7-2 and number 7. Let's take a look at the answers for it, and let's take a look at. That's what I thought too. So let's go with it. So first things first is if you were to solve this, what, by substitution or elimination, you get yourself infinitely many solutions, correct? So you get yourself that, and then the graph of it should tell you. You have a graph. Notice there's only one graph on the graph thing. And so because of that, you have one line that's regularly on top of the other line. We're good?
How do we get that A?
I know. Let's go with it. Let's explain as we go.
Yeah, no, I saw that, and I'm like, I don't know where the letter A came from.
So notice a few little things. It's just saying this. It's saying that whatever, if you have infinitely many solutions, that means this is an answer, that's an answer, that's an answer, that's an answer, and then you go on forever. We're good? So now the question is this: with infinitely many solutions with only 2 terms or with only 2 equations, we actually do know what those are, because over here, is this an answer as well or no? No, it's only the ones that are actually on the line, right? So then how do you say this? How do you say all the X's and Y's that are on that line right there? And the way the book says it is this right here.
Sure.
If you solve this guy for a Y, what do you guys get?
Oh, so we do the slope.
2y equals 3x minus 5.
Subtract 3x from both sides, divide by -2. And you get ourselves y is equal to what? 3/2 x minus 5/2. Is that right? Something looks like that.
Oh, that's right.
In fact, if you did this one and solve for y, you should get the exact same thing. All right, so if you add, let's see, if you add 6x to both sides, divide by 4, reduce, and of course you should get the same thing because you get the same exact line. So now the question is, what is your solution set? What are your x's and y's that make that true? Well, your solution set is any a value that you ever want to put in for x, but the y value is going to be that right there. Oh, sorry, a. If a is our input value, then our y value would be that right there. Does that make sense?
Oh.
So any x plugged in and the y value will be of this nature, or that's where it's going to be positioned. So if let's say a is going to be our like -3. A is -3, then I can plug in a -3 into a, and it should give me a point that's on the line. Yeah, we could have, I mean, they could have just done it like this. They could have, that would have been just fine as well, right here. So any x and any y value that's of the form of 3/2x minus 5/2. I think they would put a in there so it doesn't confuse you between the variable and a point. I think that's why they put a, which is then just confusing. So this only happens with two equations. Once you get to three equations, then we don't know what that relationship is for infinite many solutions. That gets all really crazy. Okay, 7.2, number 7, good now. Cool, okay, any questions on 7.3? That's the next one that we were looking at here. Everybody started 7.3. Okay, my only thing for 7.3 is watch your multiplication, because there's just that one slip of multiplication, then you're just done, right? Because then it doesn't work. That's the only problem, is the fact that it just keeps on messing you up as you go through it here. Okay, so 7.3, some people are still going to do it. Is that right? So let's jump to 7.4. We have 4 problems, but it may just take us a while.
Just technically in the future, but not long.
Yes.
Or but it could be involved, it's just like anthropomorphic cars in like the middle of the desert.
Everything mutated from the earth by the trash.
But then
Let's just take this.
part of it sees that the earth is completely destroyed and there's still people in advertisements involved. So then
Maybe it's like.
Are we to Wally now?
no, because the people in the chairs, so what if the people are still too young to walk around? So then they made themselves little cars to move around in, and then they became the cars. We just cracked the code.
So, hey guys, in Wally, you know the scene where Wally gets struck by lightning? His battery fully charges, if you look closely at the scene.
That's funny. All right, guys, all yours here. Can you simplify this? So now we're getting into the sort of the applications of systems of equations here. So one application of systems of equations is in math applications, something called partial fractions. How do you undo adding fractions together? That's one. Second, we're going to look at inequalities of this stuff, and then applications of those, and then we're getting into linear programming in 7.6. So kind of we've learned 7.1, 7.2, 7.3 was pretty much like the learning how to do them. 7.4, 7.5, 7.6 is actually the application. Why do we apply them? So math application, where do we do this? Or how do we use this? Let's go with it. So first things first, can you guys do this here from algebra 1 right here? So 2 over x minus 3 plus negative 1 over x plus 2. Can we add this up together? Hopefully.
Oh, you have to make them the same.
Yep, you got to get common denominators.
Look at that.
X minus 3, x plus 2.
Minus x minus 6.
So let's see, if we get those as the common denominators, that means this guy has to have an extra x plus 2 there, is that right? We got a multiplier there. This is a negative 1 and an extra x minus 3 as a multiplier there. Okay, so almost running out of room here, but I'm going to keep just for the sake of the, I'll keep it just like this for now here. Okay, denominators are still the same. We're going to add this together in just a second here. So this is 2x plus 4, everybody agreed there? Jump this way here. This is negative x plus 3. And at the end of the day, I give myself a, you know what we'll do? Let's multiply this denominator just for the sake of this section.
Minus x minus 6.
Are we okay there with the denominator? And top?
Yep.
X plus 7. Okay, are we good there? Done. Yay. That was algebra 1. Did you guys like these from Algebra 1? They're okay. All right. Okay, so application is this. In mathematics, particularly in calculus 2, where we do a whole bunch of different things called antiderivatives, we need to learn how to break up fractions back into the equivalent parts. So this is going backwards. We want to go from here back to here. That's our job for today. We break this up into going backwards. So exercise number 1. Let's go with it here. So write the fraction decomposition in this right here. So that's what we're gonna do. So it's called decompose, fraction decomposition, or decompose this fraction. Right. So first things first, I'm going to factor the bottom. Whoa. Do exact opposite of what we're doing here. Tell me if you guys agree. This is the same thing as top numerator stays the same, but the bottom is x minus 3x plus 2. True? Cool, cool. And if that's true, that means somehow when I added these guys up, one denominator was x minus 3. The other denominator was x plus 2. Just assume. Okay, we don't need fractions. We don't need the little parentheses there if you don't want to, because now they're individualized. Okay, so how do we do this? What we do is we say this. We say that means some kind of a value was here, some kind of b value was here.
We're not going to multiply them because you don't add x minus 3 and x plus 2 and multiply them.
True, true. When you put them together. So when you break them apart, way in the beginning, one fraction had an x minus 3, one fraction had an x plus 2. So now the question is, what's the a value? What's the b value that makes that true?
You have to multiply them, right? So we could put a of x plus 2 over x minus 3 times x plus 2.
Cool, Abby has a good idea of it. So here's what we're gonna do. We're going to get rid of our denominator. By getting rid of it, it actually makes it a little easier to think through here. So let's see if this makes sense. We're gonna multiply all this, both sides. So essentially multiply both sides by an x minus 3, x plus 2 here. We multiply this by the same thing. So everything gets multiplied by x minus 3, x plus 2, x minus 3, x plus 2. And what happens? This is just x plus 7, because those both fractions canceled. This one now is a times x plus 2. Tell me if you guys agree. This is b with a x minus 3.
Times x plus 3 times x plus 2.
A times x plus 3 and b times x minus 3.
Can we
So x
find
plus 2.
the value for, can we find like, put a on one side and then divide? Just find like what a is in terms of the equation, and then we can plug it back in and do the canceling out.
That's so cool. Okay, so we can do that. Would be the little bit of the longer way to do it. But yes, that would be the proper sort of way to do it. We're gonna do a little trick here. We're going to get rid of one of the variables by introducing a certain x in the process. So something that would make maybe like a go to 0, a go to nothing.
X minus 2. Or x equals -2.
Yeah, we're going to plug in. So let's do that here. So here's what we do. We plug in an x is equal to -2 into this process. Because what's going to happen is it's going to get rid of the a values for us. Now it's kind of like what we've been doing in systems of equations. It's almost like we're eliminating the a. We good?
And B is -5, so that's -1.
Running out of room here. On to the next one. Is it it's 5 on one side, is that right?
Yeah. And then.
A times 0 is nothing. B is what, times -5?
Yeah.
So I got 5 on one side. And I got a -5b on the other. Divide through by -5. And I got b is -1, which is real quickly here. Let's go back to our notes here. What was the number when we started that was over x plus 2? Everybody okay with this guy over here, -1? That was -1, okay. So let's jam with the next one here. So go back over here. What should we use for x to cancel off the b's?
Wait, can you go to the next one? Also consider moving.
Let's go back over here now. What x1? 3. Everybody good with 3? X equals 3. That will eliminate the b now. And that will get us our a value that we need. A little bit shorter, but maybe better. So if I say x is equal to 3, that's what I'm going to use this time. Let me jump back to my little x plus 7. That means this is, well, 3 plus 7. 3 plus 7 is here. 8, and a is 3 plus 2. Is that right? And b is 3 minus 3. Okay, cool. I think I got it. That's 10. That's a 5a, and that's 0. Divide by 5. And we have ourselves a is equal to 2. Are we good? That is so cool. Done. I got myself. Okay, we can write it like this here. 2 is equal to a, whichever way. But that is it. So then what did I do? I have decomposed this fraction from x plus 7 over x squared minus x minus 6. And now the answer is x minus 3 over 2 and x plus 2 over -1. Are we good? Again, just application of this stuff. Does it get complicated? Yes. Does it get to the point that we need 3 equations and 3 unknowns and we're trying to figure things out? Yes, we're going to get there. So let's jam. So next, exercise 2. It is a bit dry, I got to say, because the only time we use this is in Calc 2. When you guys get to Calc 2, then it's awesome. Then it's like, oh, that's how I undo an antiderivative. Until then, it's like, okay, yeah, I get to break down a fraction. That's no fun. So sorry, guys. Okay, long problem, but let's get started. How about this? This is going to be we have 2 things happening here. First of all, this guy is a improper fraction. That's the first thing that's a problem. Notice the thing on top, x to the 4th is bigger than x cubed. So we have ourselves an improper fraction.
Is that last one 6?
Plus 6, yeah. Ready for the no fun part?
So,
We have to make this into a proper fraction
no, I'm not.
by doing
I'm not ready.
long division.
No.
Oh.
No.
This is.
Actually, would you mind just like,
Uh-huh.
appreciate it.
I'll give you guys pins to stick in your eyes on Friday. I'm trying to figure what would be. I think this would be the best way to do it. Okay, so let's do this here. Man, long problem. Here we go. X to the third plus 2x squared plus x. And then how many times does it go into x to the fourth? Say that again.
Yeah.
No. How come we can't use synthetic division, guys?
Because it's not linear.
It's not a linear divisor. Yeah, if it was x minus 2, x plus 7, then we could have used that.
Alright.
Oh,
How
man.
many times is, yeah, I can't remember.
All right, let's see. So the question is this: how many times does x cubed give you x to the fourth? Or what do you multiply?
X.
Just an x. So notice, oh, we're all the way down here already. That's good,
It's not
Right here.
because then you get later on.
right? It's the x column, right? That we. So if we do that here, x times that gives you x to the fourth. X times that gives you a plus 2x to the third. Oh, interesting. Okay, x times x gives you x squared. And then remember what we do is we subtract, but even better yet, we add opposite signs here. So that's an opposite, that's an opposite, that's an opposite. And see what happens here. So this guy's gone. This guy's gone too. Love it. Okay, so this is just 5x to the second. Bring down the 20x, bring down the 6. And so now the question is, what multiplies x to the third to give you 5x squared?
5, 1 over x.
Ooh,
Down an exponent.
That's what I was
good,
wondering.
good. You can't go down an exponent, so we're done. That means that's the
No,
remainder
that's
right
a
there.
disgusting remainder.
Nice.
So,
Love that for us.
Here's what we got, x plus,
know.
Let me just
They should have upgraded the war.
This is.
all right, there's our, not bad. I thought it was gonna get at least a lot more ugly than that. Still bad?
It's still
Sorry,
bad,
sorry,
just like a little bit.
sorry.
Just kind of
Like, no. You know?
Okay. Share my friends. We are in algebra too. Oh, in statistics. Once in a while, like, we did this in class today.
Look at how much fun you have to look forward to. Oh my gosh. Love this so much. The loss
So what do we
division.
do now? It's a
Factor.
proper
I don't know.
fraction.
We factor, put it into the box and then factor.
That's, okay.
You know what, that's a mood.
Do we
Okay.
box?
Just
it? I
decide
just
that.
box it.
If we said that,
We could box, yeah. So now, let's see, we have to, so it looks like we're adding x, but then we're adding some fractions together. These are the fractions that we're gonna have to figure out right here. So can we
Those are added.
decompose that piece right there?
Yeah.
that one's x squared.
Okay,
plus
so let's,
x
yeah, let's
times
concentrate
x
just on
plus
the,
1, I think.
So we got the x in front. Let's just concentrate just on the fraction itself here. So just on this guy here. Over. Write it so the way the book does it here, there's that. And what did we do last time? We factored out the bottom, is that right?
Yeah, I
So can
did
you
the
factor?
factoring box method.
What
and
did
so
you
then I
get?
got well, I did it in my mind, so I got x squared plus x times x minus, or plus 1.
Huh.
X squared plus x times x plus.
Gotcha. So notice that we have x's all the way across. We could pull out an x already, right?
Oh,
That's
yeah.
what, at first, and then we'll do the box method. There's that, and then and this one becomes x squared plus 2x plus 1. Anybody?
X to the third plus 2x squared plus x.
No, we're multiplying it out. I'm trying to factor it out.
X plus 1 squared.
Yeah, this one is an x plus 1 squared. So there's 2 factors here. Okay. I think we're good here. Okay, let's break this up now. So I have myself 3 different things here, and it's because I have repeated factors here. So let's go with it. So I got a over x. I got a b over x plus 1, because that's one of those factors. And then I'm going to go up in my powers now. So this is going to be x plus 1 to the second. So it could have been that it was an x plus 1, could have been there was x plus 1 to the second originally. So yes, each one of those factors need to get 1.
Wait, why did we do that?
Because it's like all the different factors that go.
All the different possible ways I can get that formation here. So if you could have a degree, it could have been it was a degree 1, it could have been it was degree 2 already, it could have been there was a combination of both the degree 1 and degree 2. So if you have repeated factors, you have to put each each power of your repeated factor. Oh man.
I'm gonna understand that and do it so well.
Yeah, same.
It's just gonna go so smoothly.
I did try not to torture you too much, so I didn't put too much homework questions like this.
Oh, thank you. Thank you very much.
Okay, let's see. What we do now is we multiply through by the common denominator and we get rid of stuff. So let's see if we can actually do that. Just kind of thinking through right here. So this would be, this guy does not have denominators anymore, true? This one is going to drop the x completely. But what does have it next to it though?
So what are we multiplying by?
By the common denominator.
Oh,
So it's this piece right here we're multiplying by. So this one drops off. Yeah, this, everybody okay with x plus 1 squared over here? So the x is the only thing that drops out, but the x plus 1 to the second power is there, okay?
But why exactly?
we're
Mhm.
getting rid of the denominator on
And
the
then it's
left,
x,
so that
right?
it isn't a fraction, so we can solve.
Nice.
Hopefully.
And then it's x times x plus 1.
This would be x times x plus 1, right? It's the remaining factors if we multiply through. And this one,
X. It's x.
it's just x. Okay, talk to me. This is a crucial point here. Did you guys see where all those pieces came from?
Yeah, so it's like the stuff that gets multiplied, it gets rid of the bottom, but then you still have the remaining things multiplying.
Yeah, so if you multiply through by the common denominator here, that x canceled, but then you still have x squared. Good there. Then you have, as you multiply this guy together, the x stays because there's nothing to cancel that one, and this only cancels with one of these guys. So x and then x plus 1 stays. And then as you do this one, nice, the whole entire x plus squared,
Okay.
but then x stays.
Now we put in a number to make one of the variables 0.
0.
There you go.
Proceed to make it.
Yeah. we can
Okay,
do that
0.
easily.
Let's try 0. Okay, on the next one, let's go
So
with
then it would
0.
be 6 equals a x plus 1 plus bx times x plus b. Wait, if it's 0, so then that would just be 6 equals 0.
Let's do this here. Let's do
Because you're multiplying everything by 0.
Oh, yeah, everything would be gone, so we can't do that.
Or wait, no, because it's 0 plus 1 squared, so that would be A plus,
No, everything would be
no,
zero.
so then it would be 6 equals A, right?
No, A is also multiplied times X.
No, but it's multiplied by X plus 1.
Right, it would just be A left.
So then,
right?
yeah, so then it would be 6 equals A, right? Because B
You
is
could do
multiplied by
that,
X.
'cause it-
Yeah,
you
so
have
then it
your
would all
head.
cancel. What?
You do that in your head?
Yeah, so then it would be
I
6
actually already
equals
solved this
A,
problem
right?
a long time ago.
It's
only random.
Let's do this. We could go 0, that'll be fine. We can go -1 as well, right?
A equals 6, right? Because you're
We can-
canceling
we can-
all of them out that multiplies by X. A doesn't directly multiply into X.
Which one do you want to do? X equals what?
0.
0. Okay,
Yeah, because
right.
cancel out B, cancel out C, cancels out the
so
first
cancels,
two
cancels, cancels,
values.
leaving us with a 6 on this side, is that right?
Yeah, 6 equals A.
Because this is all gone.
Has 17.
Then over here, it's going to be A.
Don't you dare bring back this.
No, it's smiley has, what was it, smiley, curly, and.
I remember that.
Yeah, we already know that B is gonna be 0, because multiplying anything by 0 means that it's 0. So we can cancel out B and C, so then we know that C, 6 equals A.
Yeah.
Like I said,
Done.
yeah.
Cool. Any other way we can cancel anything else out?
We could do.
So let's go back over here. So I got A is equal to 6.
We could do C equals, we could do X equals -1 and then get. rid of A
-1.
and
I'm not
B.
disagreeing.
Yes, okay. You guys go with it. X equals -1.
I think that works.
Plug that in.
You know what, Noah, you're completely correct.
So -1 into here, -1 in there.
So that would
So that would mean X, or
negative.
sorry, that would mean C.
It's 5x.
So it'd just be, it would
it's
be
just
5
positive
minus 20
five.
plus 6.
Yeah.
So then that would be
I don't understand.
11.
This doesn't make sense.
So
Just
then
plug in things and get rid of variables. No, it's not that bad.
I understand what we're doing now, but I don't understand what we're on.
Exactly.
What do you not
negative
understand about?
9. So that would be -9, right?
Everything, literally everything.
Wait, Abby, it's -9 equals.
Why do we multiply that by that?
So if you want to
Circle
get
it
rid of
all.
this, right? So once
Okay.
we simplify it down, this is dividing, so if we multiply it by that, we can get rid of it. But when we multiply on the other side, look, see when we multiply, those x's cross out, but the x plus 1 squared remains. Because now you're just multiplying by 0.
But then
this
we get
is
rid of-
x plus 1 squared, so when you multiply by the exact same thing.
So
they
then it's
cancel
equals
everything.
9.
But these are not the
Right?
same.
C is
So
equal to 9.
the x
Yeah.
cancels out.
No, it does not.
Oh, enlightened.
It is not, Joe.
So that's why we get all of the remaining.
Now I
So then,
I'm good, yeah.
Wait, you see.
yeah, C is 9.
Betrayal. Oh, no,
Yeah.
no, no.
Yeah.
Well,
C equals 9, that's all you need to know.
thank you. I'll write this down.
This is
tonight.
9 right over here on this side?
Mention.
Obviously, because that's just gonna help you understand it better.
-9 on this side, is that
Yep.
right? A's are gone,
-9
B is
equals
gone.
negative C. So then C equals 9.
Done, okay.
He's
So
calling
now,
off the marriage with Lou.
let's see, now I know that A is 6. Okay, guys, I know this is dry. Totally understand, guys. I feel for you. It's just a process and eventually like, oh, great, we're done. So real quick here, we have 3 different variables, is that right? We already know 2 of them. We know that A is equal to 6, C is equal to 9. We know that for sure, right?
Yeah,
There can't be anything else.
absolutely.
Okay, if that is the case, then let's just plug in any number whatsoever. We don't necessarily have to cancel B out because that's been canceling out. Because whatever number we plug in, B is the only variable that we have. We good? If that makes
do
sense?
1.
Let's do 1, okay.
Make
So
it
we're gonna go
easy.
X equals 1. 0 we already used to cancel off because it canceled the other ones, right? Aw,
6.
20 times 1 plus 6. And now let's go with, I'm going to go back row 2 slides here now. Ding, 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 ding. Let's see, a is equal to 6, true? This is 1 plus 1 squared plus b, we don't know. X is 1, x plus 1, 1, plus 9 times 1. Okay, you guys, again, carefully look at where all these numbers came from. It comes from right over here, just plugging in a 1 in for the x everywhere. And then also plugging in 6 for A and 9 for C, now that we know those. So it's really a puzzle. It's like, okay, if I don't know this, I don't know this, what can I eliminate to find that piece? Once I found the different pieces, then I can
So
eliminate.
then B is -1, right?
B should be -1.
I got 32.
Ooh, okay, let's try it here. So this is 5, this is 20, this is 6, this is 2 squared. What is that, 24?
Yeah, because it's 6 times 4.
24, 2b, and 9.
The way that I did it is I just saw
31.
that it was a 20 already, so then I just did 5 minus 4 because you subtract 24 from both sides. So then the 20 would turn into a -4. So it's 5 minus 4. Then you also subtract 9. 6 plus 3 equals 9. So then I did 5 minus 4 minus 3 to get -2.
I think your brain's
And
operating
then-
too well for this early in the morning.
Oh, it's because I had this near-death experience. So then like my brain's just all the adrenaline. I'm just like,
The near car crash has really helped you.
technically it
Uh-huh,
wasn't
yeah.
a near car crash because no, it wasn't a near car crash because I ended up like going through the light, but it was still scary.
You ran on a red light?
No, of course I didn't run a red light.
That sounded like you were saying.
What did you do, Alaka?
So my mom, I was going up to the thing on LOB. But your dad owns the car.
Oh, okay, guys, I'm gonna write what we found out. Are you guys ready for this here? So this is what we just found out.
8 is 6. Don't you see
I
it's
have
not
a separate paper for
My
work.
dad's tractor, my dad had a tractor in what's it called, in a trailer, and he forgot to put the emergency brake on it in the tractor, and so the back of our car is now crushed because when he stopped, the tractor rammed into our car.
Oh, ouch.
So he just destroyed the back of our car for the 3rd time, not the first, not the second, but the 3rd.
Ouch, okay. Okay, guys, here's what I got. I got the fraction decomposition of this guy, which is, it was improper fraction to begin with. So we did have an extra x over here. And then we found out that A was 6, B was -1, and C was 9. Oof, okay. Sorry, guys, yep.
So like, how is this
Okay.
information helped us? That's what I need to know.
It's one of those in
They just want
algebra.
us to find the information. They're
Yeah.
like, how can I make them suffer?
I'm
Find
just
this
like in the
random
grocery
number.
store when I'm like buying some like.
But like,
Is this
what-
how you do
what-
taxes?
What job is like works with this
I
problem?
feel like this is a fair part of my job to say, when am I gonna use this in my
Uh-huh.
life?
I mean, he said it was in calculus too, so maybe when
Once you
calculate.
get past like 8th grade math, if you don't want to go into like a math like type of career, you don't really need like.
Thank you.
Mhm.
I would like to know.
So yeah,
if
so
what
in
job-
math world, when you use this is, again, second semester calculus, right? The mental process that I think math builds here is the fact that if you're trying to solve a complex problem, you're trying to isolate in each individual pieces of the problem. And so if you say to yourself, okay, hold on, I'm gonna hold off that for a while. Let me just solve this aspect of this problem. And we do it with numbers.
There's still a mathematical equation for whether or not you should do that.
The taste, what I'm hungry for. Is there milk in the refrigerator?
The question is actually, why not both?
There you go. So, but I think this lends itself. I think a lot of times in mathematics, we're just dealing with numbers all the time. But there's almost an overarching like thought process that we get into. So I think Elika demonstrated it in the fact that, hey, you know what, if we need to eliminate this from this process, how do we think about this only in terms of the other two? And so
No, that's just how I work through things. This is like my mental process. I'm just like, okay, there's a big problem. Then I focus on one part of the problem and then put that into the bigger problem and find a result.
yeah, I think we do that. Let's see.
Oh, no, big problem, brain shut down now.
Let's see, we had one experience where we were down to 2 cars, but kids had practice, I had work, other daughter had work. And so it was this kind of process right here. Okay, the kids need to go to school. When do they need to go to school? Okay, this one. Okay, do we have a car then? Yes. Okay, daughter goes to work, and that's not going to work with this one. So therefore, hold on, let's let someone else take her to work. So therefore, we have the extra car. Therefore, I can get to work. So it was almost like you compartmentalize the issues at hand, and then you can actually see the whole problem as a whole. Does that make sense? That's okay, guys. I think we have time for one more. Let's try one more. And this one finally is going to get us into our systems of equations here.
Yeah, especially when you get it and then you're like, oh, I did it.
Okay, got that over this right here. Okay, this one's gonna be a little bit different from the other ones here, but that's okay. But we are gonna get into linear equations though at this point here, so or systems of equations here. I think we have enough time. Nah, even more complicated. Okay, first things first, is this a proper or improper fraction? Proper, awesome. I don't have to deal with the long division. We good? At least that. Whew. Nice, so much better. I agree. Okay, let's factor our denominator as much as we can.
Wait, so then
X pulls out,
for the bottom, can we do X then times X plus 2 times X minus 2?
No, because that would have been an X squared minus 4, but we have X.
Oh, yeah.
So, ooh, another issue we run into, guys, real quick here. I can't factor down, that looks like a funny 2. I cannot factor down X squared plus 4. That does not factor.
You could do X to Y, X to Y.
Yeah, it goes into the complex numbers, except the only thing is we're not dealing with complex numbers, we're dealing with real numbers. So we got to keep that together.
On top of everything else.
The answer is no.
Okay, so how do we handle something that we can't break down? Notice the previous one, we were able to break it down because it was X plus 1, right? And then it was another X plus 1 squared. So there was a little difference there. This one can't break it down. It's set as X squared plus 4. Okay. So then the way we break it down, let's go with it here. We're going to say, oh, you know, I can still do it over here. I'm going to say that this is A over, you guys talk to me. What is it? A over what? X, good. Our first denominator plus, now because we can't break down the X squared plus 4, here's what we do. Yes, it's going to be a B and a C. It's going to be a BX plus C. We're going to add an extra X variable to the top. Because if this was a proper fraction and we had an X squared on the bottom, we could have had some kind of X on top. We're good? As opposed to if this is just X, then it'd have to have just an A on top. Okay, I think we got this one here. Let's multiply through by common denominator again.
So why did we put the X on top?
Because we have an X squared on the bottom. So if this was a proper fraction, we could potentially have a multiplier of X on top.
Okay.
We got rid of that by individualizing our X plus 1, X1 to the second power. We did that by doing that one. Okay, so I'm going to do this here, see if this makes sense here. That's this right here. I just multiplied through by the common denominator. So that means the x canceled here, leaving us a multiplier of x squared plus 4. And this one became this times x. Tell me if you guys
Put
agree
the
there.
X into it to make it a little bit easier, so just do like EX squared plus CX.
Say that again.
Can we make it a little easier by just like multiplying it into the parentheses and doing BX squared plus CX?
Hey, that's cool. Let's do that. So this one, a little bit different here. So let's do this here. Let's put our x squareds together if there are any. We're going to put our x's together and then we're going to put our units together. So this is ax squared plus 4a. This is going to be, oh, look at that. There's actually an x squared here. X squared plus cx. So here's what we're going to do. We're going to put all our x squareds together. So this is a plus b to the second power. And let's see what else we have. We have c to this x, that's it by itself. And then we have a 4a by itself.
Yeah, because I thought that was easier when we multiply by 0 to find the a, so that way you can just like look and say, oh, cancel out that first one, cancel out the c, so then 4 equals 4a, so a
Perfect.
equals 1.
Okay. So guys, real quick here, as we do this to finish up, notice you have a polynomial here. This is something times x squared and something times x and a loner. We have something times x squared, we have something times x and a loner. We're going to make a systems of equations out of this. We good? So here's what we do. We say to ourselves, look, for this to be true, the a plus b would have to equal 3, true? That part would have to be equal. So c would then have to equal 4. And then 4a would have to equal 4. So let's actually make a systems of equations out of this here. So I'm going to say this. I'm going to say a plus b, leave a little space for c. That one is going to have to equal 3 for us. Let's go back again. So then this guy, c is equal to 4. Oh, that's cool. C is equal to 4. And then 4a is equal to 4. So this one, 4a is equal to 4. Does that look like it's not XYZ anymore, right? It's ABC.
Wait, so then we know that a equals 1.
Perfect. Okay, so looking at this here, what can we find out? I'm going to do this one first, though. This
Then
one's
b
easy.
equals 2.
Can I do this one real quick here? C is equal to 4. I know that for sure.
Yeah.
Then because of this equation here on the bottom, I know that A's has to equal to 1.
Do 1 plus b equals 3, so then b would be 2. Yeah.
Perfect. Yeah, I got that one. And then my top equation means that 1 plus b is equal to 3. Therefore, b would have to be equal to 2. Done. I have isolated those pieces. So it's isolating those pieces individually. Did you guys, when you guys were younger and probably middle school or something, did you guys do those logic puzzles?
Yeah.
Like one person came in first, second, and third, and it was Mary. I was Chris.
No, it was like Smiley,
And-
Curly, and Balthazar or something.
Whatever curriculum
Yeah, I
goes
can't
through, you
remember
have
the
these world's longest names.
I know, right?
No, like 16-digit names.
I had to
Wait,
wait
how do
those
you say
36
I can't
letters.
remember what thing it was, but it's like your
And,
skateboarding cousin.
With one school, we did
I
one of
was-
these and
no,
all
no,
of
mine
them.
is so funny. In this one equation, I can't remember
Wow.
even what textbook it was, but
We're not
whenever they have,
that day.
I think it was a physics textbook where they were like, your skateboarding cousin just rocked where he goes to the skate park and does this.
That's funny.
It does, rock.
So real quick here, you guys remember this right here? So it was like first and second and third place, and it was like Mary, Chris, and Peter.
Oh,
Right?
yeah, like the logic puzzle.
The logic puzzles, right? So that logic puzzle is actually of the same form, just we're dealing with numbers here and different equations. But here, right, is that Peter did not come in second. So then, you know, okay, well, I'm going to do that right here, right? Or scratch it off, sorry, then whatever's remaining. So that's a logic puzzle in terms of phrases, right? And this is just a logic puzzle in terms of just numbers themselves.
What are the letters?
Say again?
What are the letters?
You just do the, and then it works.
Okay,
Myself
boom.
getting confused for right to-
So I want to see if there we need to do any other one.
Like, right?
You just gotta plug it in.
You just gotta like turn off your brain and then just do it.
That doesn't sound like a.
Let's see, on the homework here, I have, I think I just have six problems. 1, 2, 3. 3 of them are very easy. The other ones are a little bit more complicated here. Did we finish this one up? Oh, I have to write it now. Huh? That's right. Let's write it. So this is 3x squared plus 4x plus 4 over x cubed plus 4x. Okay, how did we decompose this?
1 over x plus 2x plus 4 over x squared plus 4.
Sorry, let me go.
What?
B was 2 and 4. 2 was B, 4 was C, and that was over x squared plus 4. So there's my fraction decompose. Yes, yeah. We got ourselves checking the time here. It's not loud at all.
I may come here. Time for a clean enable. How dare you.
Are you okay?
Was it a joke?
It's fine.
A joke.
I was only joking, murder. I didn't actually like. It was only like I killed them, you know. It was only like a joke.
I understand your
This
humor.
class
Okay.
take these way too seriously.
Guys, I am done. I know we finished about 2 minutes early here, but we're good with that here. So 7.3 is due Friday. And bring questions. 7.2 is due today, yeah. So I need 7.2 or just drop it off right there next to Lily right there is fine. Yep, thank you.
Perfect. That's what they used to call me. Yeah.
I have.
That's what my day people used to call.
Okay, let's see. Give me. Let me just thumb through it. You finished off the ones that you ever asked me, like this one here, Steve, did you finish off, like you need to give me the, right? So you need to do those.
Okay, I missed that. I'm
That's
sorry.
okay. So 47, do 47 and then do, I think this is not done. I think 7 was not done.
This, it was,
Okay, solved it. I still need to solve it. So I need, at the end, I need commas and I need coordinates what is solved.
okay,
Okay,
okay. And then I
that's what
have
I'm looking
7.2 in there.
Okay,
So I'll drop that off over there and I'll finish those two tonight.